So we've been waiting.
Oh, in case you didn't know. Hey, everybody. We're Pod 5. I'm Mitch. This is Nick. I'm Dan. We had the Leap Motion and Leap Motion SDK. So we're going to talk about Leap Motion and you.
Yeah.
Spins. All right, we're gonna break this down into 3 parts. I'm gonna present the first part. Dan's gonna take the second part, and we'll finish it up with Nick on the third part. So we're gonna talk a little bit about what the Leap Motion controller is. So one of the couple pieces of hardware that we're gonna be dealing with in this project is the actual Leap Motion itself, and that's this device right here. So this is what's going to be physically mounted to the monitors that we're going to be working with. How this works, it's basically just 2 cameras, infrared cameras, and then LED infrared emitters. And so it just projects infrared light, 2 cameras picks it up, and because it's 2 cameras, it uses stereoscopic imaging, which then gives us depth. So you can control with a fine-tuned granularity positional data in X, Y, and Z in front of the camera. And it does give options in software to allow it to sit facing up, sit head mounted, or on top of the screen, which is probably what we're going to end up using it for, I would imagine. It does have embedded processing in it, so it does a lot of the work on it. It is pretty power hungry, which we're running into with the Raspberry Pis, but we'll go into that a little bit later. All right, so there's a few technologies that Leap Motion has. Their most recent is UltraLeap Hyperion. So this is the actual controller technology. If you have a Windows or Mac or a x86 Linux, you'll actually have a control dashboard. You'll be able to see the camera at the raw camera output and everything. The one that we're primarily going to be working with is UltraLeap Gemini. And the reason for that is, well, it's the only one supported on the ARM architecture of a Raspberry Pi. And if you remember, Raspberry Pi is the primary computer that we're going to use behind the monitors to control the cameras. So UltraLeap Gemini, it's fairly basic on the Raspberry Pi, but easy to use once the environment's set up. The package with each of the technologies, like Gemini, is the Leap Motion SDK, which includes the API LeapC. It is C. If any of you are familiar with C or C++, it's fairly easy to use. But considering this class is going to be using Python, we did go ahead and set up Python bindings, which we'll go into a little bit later on how to set that up. Uses of the controller, well, I mean, there's a lot, mounted to VR headsets. If you actually walk by Light Lab, sometimes you'll see people in there with them on their VR headsets using them. And interfacing with their PC. One of the technologies that Leap Motion has is touch-free. It's very interesting how that works, and it works very well at turning any monitor into a touch screen, and it's pretty precise. And I mean, endless possibilities. The uses of this in this ever-growing AR and VR landscape they're becoming more apparent. So, yeah. Now we're gonna go to Dan.
Right. So yeah, we've covered a little bit about the Leap, a little bit how to use the Leap, but now we're going to get into getting started, installing, downloading everything. So let's go to the next one. So step 1, we're going to download it, and I'm sure you guys have downloaded stuff before if we're this far in this course. But yeah, so you'll probably have to make an account once you get up there, but it's free and it shouldn't really be much. One note, make sure you don't change where you're installing it, because when you're installing the Python Leap bindings later, it could result in some pain. And next so this is a video. I'm sure you guys have all pulled repos before, but just in case. And all of these videos, everything that is done in these videos is provided in a document. So if you're wanting to glaze through these and you just want to copy and paste, that is also up there as well.
Are the documents on the GitHub?
What's that?
Are the documents on the GitHub?
Yeah,
That's
I
what I want.
I pushed the
Okay,
document
awesome.
last night. Should be good. Yep. There's LeapC Python bindings. Just clone it into a folder. And this is just to get set up on your local machine, so you could run, like if you plugged in a LeapC or a Leap motion controller and you wanted to run some stuff on your local machine, these are the steps you're going to want to go through. All right, so we've got the Python bindings. Next step, setting up your virtual environment. So we're going to open up VS Code, and in the terminal there, we have lots of commands to run.
And all these are in the document.
Yeah, all of these are in the document. Just make sure you're in the right directory. I didn't realize how tiny the text would be, so I apologize. Yeah, so here we're just typing a command to set up that virtual environment. And then it's thinking, huzzah. All right, next we're gonna activate it. There might be an issue. I ran into this issue with like execution policy on my computer. So there's also documentation on how to adjust that and then refix it so you can activate your virtual environment. Also, side note, I don't think any of us have Mac computers. So we don't know 100% how to do it, but we're absolutely happy to help you. All right, so we've got our virtual environment set up. Next, maybe, we're going to build the Python bindings. All right, so in the same terminal that we were in, just showing you here that if you want to read through the documentation, this is the file. Also has all of the commands. And here I will go line by line and install the Python bindings. Yeah, nothing really too crazy. Make sure if you're out of directory, you need to point which folder, requirements, or whatever file you're using. Other than that, it's pretty easy. Also, if you don't want to watch the video, we have it on documentation. Copy and paste works just fine.
I would imagine this is also on the GitHub README file for the Leap Motion C bindings.
Yes. Yeah. Right there. And then super interesting stuff.
It's fairly straightforward.
Mhm.
If you do end up altering directory locations, that's when you run into the need for environment variables and stuff to point it correctly, because it defaults to specific paths. So that's just something to keep in mind.
Which you can do if you want. I personally wouldn't recommend it. I have run into many problems because I thought it was fancy schmancy, and I put the SDK in a different folder than it was supposed to be, and everything was supposed to run off of that, and I deal with a bunch of different environments. It wasn't hell. It was hell. Don't do that, please. Do not do that. Like, do it if you must, but you're on your own, basically. If you run everything in the default directory like it's made to, it'll go just fine. If you need any questions, if you need any help, just come to us. We'll be able to help you out.
Yeah. No, there's a lot of areas in this whole process where, something could possibly go weird, and we encountered lots of that. So please, we'll share in the pain. This is a group project.
It sure is.
So yeah, we're still finishing up installing here. Getting to the good stuff. Yay, we done. So now, if you want to go into that examples folder, you can pull one out. I pulled one out into the root. My mouse was giving me problems.
This examples folder comes with the Python.
Yeah.
It's like it's gonna come with that.
I know. Okay. Yeah, I started this video to use a camera, and alas, I did not have a camera. So I committed to the bid. And yeah, you can just go over once you've got your Leap plugged in. See a little visualizer sample here. Maybe. Yeah. Thumbs up. All right. So that concludes step 4.
In the
Step
spirit of
5.
Halloween.
Profit. A very, very humbling photo of me. So
Is this actually from the Leap?
That's
yes,
from the
that
Leap
is
Motion
from the
camera, yeah.
Leap Motion.
We were
control
like,
panel.
we should put something here. And then we just took a screenshot.
All right. So next, my friend Mag will take over.
Hi, I'm my friend Mag. This is the part where I tell you how to use them. So now that you have hypothetically all of the Python bindings set up, this is the part where y'all come in, because y'all are going to actually have to be developing stuff using this, our app that we're going to have all in the hallways. So there are important things that you need to know that are also in the LeapC SDK themselves that the Python binding kind of interprets, which are a few important classes. One, and I have them in a specific hierarchy here. One is going to be the connection itself. The connection itself is treated as a class that everything then inherits from. The listeners specifically are inheriting from the connection class. And you can see I starred the listener class because that's like 99% of the class that you're going to be worried about. The listener is the thing that actually handles the events from the camera. Everything, every single thing that the camera sees, the events, hand motions, connection events, disconnection events, errors, everything on that is going to be handled through the listener, and you're going to be grabbing through the listener. That's the most important part. You're going to be doing the listener class itself a lot. And that's pretty much what it's called. And of course, with the way Python inheritance works, you can call the class anything, but it's essentially just called the listener class. And an event, as you see here, is just anything at all logged by the camera. That doesn't just have to be hand movement, although it absolutely is hand movement. Of course, that's going to be most of what you're dealing with. But it also includes stuff like connection, disconnection logs. That's going to be stuff like other camera events, like if there's some sort of error, bunch of different transcript stuff. You can get stuff like the serial number from it, et cetera, et cetera. Events is like a whole thing. And you can see here, this is just from one of the Python binding examples. You can see they start, don't worry about connection just yet, but they start with a class listener right here, and it just little says base class, custom listeners and connections, fair enough. And then they have defined on event, and so they have an event class of event pass through. And you can see, and what that defined on event function does is it's called every single event, which 99% of the time is going to be every cycle. Because event, like I said, could be almost anything. So every single time some event happens through the camera, that function is designed to be called. So what you can do is you can override this listener class with your own and override this on event function with your own on event function to do something you want per event. And that's mostly how you're going to be handling 99% of all the stuff that you're doing. Now, what specific types of events there are? There's a lot. There's a lot of them. You can see here they came up with a bunch of different functions that you can override whenever you wanted, and the full list is here. You're not going to worry about in most of these. There are some ones that you're going to be worried about more of them. Like, for example, event type.connection. That's just on a connection event. If you want to tell whether or not the camera is connected, obviously it's kind of important. That just will fire off on any connection event. And the most important one is going to be somewhere. You all see tracking, right here. Thank you. On tracking event right here. Obviously, as y'all might guess, that's going to be your most important event, because everything tracking related is stuff the camera is literally seeing and stuff that we're going to be using to do our things. But if you see here, this is one of the actual examples that it has. You can see here that they start with a my class listener, right? Where they make their own listener class, and then they define an on connection event. Like I said, they override that on connection event that was in the original Python bindings, and then they just have it to say print connected, just so you, the coder, know, hey, this thing's connecting properly. And then the actual juice is, well, they have on-device event too, just to print the serial number and stuff in case something happens, etc. But more important thing is going to be the start of this on-tracking event right here. Does this thing have a pointer? No? Okay. Oh, well.
Okay, you can use your mouse though. I see your mouse.
Yeah, but also there was like a laser pointer that's a bit more, and whatever. It's yeah, it's not PowerPoint. So you can see here they overrid their own tracking event function, and this is where most of the juice is going to be. They have, and I move over here, they printed the event tracking frame ID, and I'll explain this a little bit later, but the tracking frame ID is essentially just the frame number of whatever is tracking. So this is going to continuously go up all the time. And that's for you to keep track of frames and keep track of the camera's notion of a passage of time, essentially. And they have, for hand and event.hands, okay, we're dealing with custom data types now. Sure, events.hands, there's a hand.type apparently. Hand.id, okay, .palm, .position, .x, it's a lot. It's a lot. There's a lot of different custom data types defined by these Python bindings. Luckily, I made it so you don't have to worry about it. Introducing Mag's Python bindings. What I did for you is I condensed all of that into a few easy to use functions where you don't have to worry about custom data types. Thank you. All you need to do, literally this is literally all of the functions that you need to set up the camera. That's it. And I'm gonna show you how to do it. So step one, we're gonna import what we need. You see here, I have the name is actually different. It says camera bindings.py because I literally renamed them about 5 minutes before class. So that's going to be, it's not pinching at location example because that's a horrible, awful name. So I renamed it to camera bindings. So don't use that, use camera bindings because that's a bit more in depth. And camera bindings is a file that's not included in just the base Python bindings. That's a file that I made for y'all. That's going to be included. We have that up on the GitHub, or we will have that up in the GitHub very soon. So that, and I'll tell you what other files to get as well from the GitHub, from our GitHub. That's not included in just the base Python bindings. That's something I made. So you're going to import the file I made, and then specifically, you're going to import from that file my listener as listener. Look at that. It's a listener class. Tap again. And then you're also just going to import Leap itself because you would have to do that anyway. Step two, once you import all the stuff you need to set up that connection that I talked about earlier, and also the listening class, the listener class. So you see here, I just made a new listener, as we all know. I'm pretty sure we mostly know how class inheritance works. And I made a new connection. And this important step right here, this is the only thing, one of the two only things you need the connection class for. And this is why I put connection above listener. You're going to do a connection.add listener, and then the listener you just made. And what that's going to do is the connection that forms between this machine and the camera is going to add this listener that's able to detect and pass on events. That's extremely important. You need to do that, or else it won't be able to detect any events and it'll be useless. So make sure to add the listener you create from the listener class that you imported from step one into that connection that you made here. And once we do that, step three, you are going to open the connection. And then I put specifically with here, because if any of you have dealt with stuff like files before in Python, you use the with keybind. You use the with keyword, that's the right word, specifically so that whenever you're done with the file, it knows to automatically close the file. That's what the with keyword does. It's the same kind of thing here, so that whenever the connection, you're done with connection for whatever reason and it terminates early, it automatically knows to close the connection, just to prevent any kind of weird memory leaks, et cetera, et cetera, et cetera. It's just good practice. That's it. That's literally it. And then everything else here, you see I had just like a simple while loop here that runs forever. As long as this program stays running within this connection.open, you are connected to the camera and you can listen for events and you can do whatever you want. And that's it. It's that simple. So yeah, go ahead. Oh yeah. Here are the two most important functions that I made that we're probably going to be using. There's just two of them. One, get palm position. I wonder what that does. Step 2 is pinching. Again, I wonder what that does. And you can see right here, I will actually, because I think the next one is the, oh yeah, here we go. So I just have a very simplified example right here, and I'm actually going to show this work with me because I'm smart. So you can see I did everything here exactly like we talked about. And then I have with connection not open, and then just while true, I have it printing is pinching and dot get palm position. And wow, would you look at that? It's that easy. Now you not only have the coordinates that it detects your hand is, or rather more specifically your palm, because it does actually track individual joints. We'll get into that in a bit. But you also have whether or not it detects your pinching. And I just chose pinching because A, there was already an example included about pinching and the actual bindings themselves. And B, it was just, I don't know, I thought it was an easy way to like click or something. If y'all want to do that, we can discuss more options later. But that seems fair to me. That's all you need. Literally, that's 90% of what you need. And then, of course, you can do your various GUI stuff here should you choose to. And I believe I can show a live example here. Let us. I'm already hooked up. Okay, you do that for me. Thank you. Do I stop sharing? I guess so. And then.
We'll lose it on the recording stuff. It's possible.
No, I know. I'm gonna screen share the share screen. I'm probably just gonna share my whole entire screen because that'll just be easier. Allow, I guess. Oh, that's scary. Okay. You see everything now? Cool. Okay. So you have here, this is just the same thing that I just ran on here, except this is live. Hi, hello. And where's the camera? Okay. This guy's the camera. He showed it to you earlier, but how the only difference is it's actually plugged into my computer. And if I'm going to run this right here, we're going to watch it not work. Oh, it's working. Look at that. So I'm just moving my palm in front of it, and it's automatically grabbing the palm position. I just have it sleeping every 0.3 seconds, so it doesn't spam my console. And if I start pinching, it's going to hopefully work. Look at that. And I unpinch, and it's false. And I pinch again, and it's true. Look at that. Actual magic. But with 13 at most. So I don't know if you saw earlier. I think I have the event. Oh no, that's the event listener. Tracking event example. Here we go. Yeah, before you would have to do like all of these, and it would just print the hand example itself, and you would have to like override my listener class to find different events thing. No, you don't have to do that anymore. I fixed it. Where are we? Okay. And then next up, where's the, oh wait, no, this is the right one. No spoilers. Okay. And then I also made another example where I think the GUI people talked about tkinter. Am I wrong? Who is the GUI people? Y'all talked about tkinter? Okay. So I wasn't there for that, but I heard about it. So I was like, maybe I should incorporate tkinter. And we're doing a graphical program anyway. So I was like, maybe I should do it. So there, I did it. Now you have no excuses. I actually made it working. And again, I have this on here. We can just test this very easily. And again, both of these examples I made are also on the GitHub, or will be on the GitHub very shortly. So y'all can, if y'all want to run this on your own machine, just follow all the steps we talked about before. Plug in one of the cameras we got in the Swing Lab, which we'll talk in a bit. And then you'll have it working. You can run it. Where is it? Is it? Oh, I think it's called external class test on my thing. Ignore that. It has a better name, I promise. Cursor, yeah. I think this is the right one. Look at that. Okay, so I'm holding the camera up. I'm moving my palm around. Look at that. Works exactly as you'd expect. It's a little bit finicky in terms of positioning because I just kind of like half-assed that, but you will be able to actually do it once we start setting the whole thing up. But it's working exactly as you'd expect. Moving around. It's pretty smooth. This thing runs at a whopping 120 FPS. So we can have some pretty damn smooth movement if y'all know how to do it correctly. It's like shockingly smooth. So now you know. And the only difference that y'all need to worry about for actually having that update while like a tkinter thing is running, for example, we don't have to use tkinter, of course. We can use whatever we want. I just use tkinter as an example. Let's see here. So here is my main loop to keep the program running, right? and I have the coordinate set at the top, and I have the box moving to the palm positions. And notice here, I have get palm position 0, which returns X, and get palm position 2, which returns Z. That's very important. Y'all need to know the difference. Obviously, it tracks 3D space and X, Y, and Z coordinates, but consider that X, Y, and Z goes like this. X, Y, Z. So you're not going to worry about the Y coordinate most of the time because that's actually the depth from the camera. So 90% of the time, when you're going to be wanting to do like positional stuff in space on the actual screen, you're going to be using X and Z. Y you only want to do when you want to do shenanigans with depth, which probably could. But just so y'all know, if you do something with X and Y and you're like, why isn't this working? It's probably because you're doing stuff with X and Y. So just as an FYI. So yeah, and then I have here window.updates. The usual tkinter way to do it is just to do main loop, I think, window.main loop, something like that. But I specifically have a function to update it once every cycle because I need to do stuff in between each update, like updating the position, et cetera, et cetera, et cetera. And as she might have talked about, tkinter.main loop is a blocking function. So once you run main loop, that's it. Nothing else after it's going to run. So that's why I had to update manually every cycle, just so y'all know. Move a bit back to here now. It's very nice. Oh, and then those aren't the only 2 functions I made. I also made some more. For whatever reason, if you need them, they're not as important, but good to know that they exist. And I do have documentation for all of these, by the way. Like all of these do have doc types. They do have a little bit of paragraphs explaining what they return and how to use them. So if you're ever confused, look at that. And if you're still confused, talk to me. For example, we have get hand type, which just returns what hand is tracking, left or right. Very simple. We also have something called get pinching vectors, which is a little bit more complicated. Essentially, the way that it tracks pinching, or the way that it tells whether or not you're pinching, is by subtracting and getting the differences of the positions between the tip of your index and the tip of your thumb. Exactly. So when I say get pinching vectors, what I mean is I'm getting or I'm returning the differences between the tip of your index and the tip of your thumb from every axis. So like the difference between, if I have my thumb and my finger like this, it will return the difference between the x-axis, the difference between the y-axis, and the difference between the z-axis. So when are you going to use that? Probably never. But if you ever needed it, it's there. Maybe you want to do some kind of cool zooming function where people go and it goes, wow, and it expands, something like that. That's exactly what that's for. If y'all ever want to do that, it's not necessary. Probably won't use it, but I exposed it for y'all just in case. Some other stuff. Oh yeah, get tracking frame ID sync. That's just that tracking frame that I talked about in case y'all ever want to do it. Like if you only want to update every other tracking frame for some reason, if you don't want it to be super smooth. And I have the different syncs here. Don't worry about it. I don't feel like explaining it. Just do sync, please. Do tracking frame ID sync. It's better. You'll maybe run into problems otherwise. And then yeah, that's setting actual tracking frame size. Again, don't worry about it. If you are curious about it, I will happily explain it to you. My throat is getting hoarse and it doesn't matter that much, so don't worry about it. I think, oh yeah, and there's also a test function I included just so you can run it and then see if it works. If it prints out something, congrats, you did it. I think that's it from me. Go ahead, next slide. Oh yeah, there's my email. If you ever can't reach me for whatever reason and you're trying to do something with this and you're like, wow, I can't figure it out, just email me. I try to help you out. We can set up a time to meet, et cetera, et cetera. I can help with y'all.
There's also the pod specific channels as well.
That's true. Yeah. Please. We are pod 5. We are pod 5. So if you ever have any questions about anything and don't feel like reaching us individually, please leave a message on our public chat. We will get to you whenever we can.
Just yell in the hallway loud enough.
Yeah. Somebody will answer you.
Yeah.
And I think that's it for me.
All right. So finally, we've also been working on something else, and that is our swamp lab. So, as you can see, in room 352 at the end of the hallway, we have a little surprise for our class, a place for all of us to work on our app and
Yeah. Software Agile Modeling and Prototyping Lab.
Right. And now we have a little tour for y'all. Sorry about my finger. We decided to leave it home. My phone. That's our super high level edited version. And then Mitch got us set up on the Raspberry. Mitch and Mag both got us, well, maybe. Yeah. So, like,
All of this will be documented and put in the GitHub as well.
You have to do that, by the way, in order for it to work. Please activate the environment.
It was a rush job.
This is like what, 10 minutes?
we just got Raspberry Pis working with LeapC today.
And then that's Nick's cursor example.
Yeah.
Okay.
So it's on the disc.
Yeah.
Yeah.
They will be there for you.
You have so it can be mounted at various locations. You just have to specify where it is. Again, we're probably going to be using it in the screen top mode. With the Raspberry Pis, we are currently working on getting better power supply to them. With the current power supplies we have, they're restricted, so they barely run the cameras. That's why it was really laggy right there. So we're working on getting those. I think they'll be in a couple days or so, and then and we'll have them. But it is functional now. With the Swamp Lab, we will have a sign up out sheet on the door. Please feel free to sign it out and use it. It should be a completely simulated environment to what we expect with the hallway monitors. So 3 computers plus that, or 3 desktop monitors plus the TV. To give you guys, a development environment. So yeah, that's Swamp Lab.
Swamp Lab. And finally, I think we.
Oh yeah.
We could set up a sign-in sheet with the Raspberry Pi.
What was the question?
Yeah, you could. That's definitely a use case.
For
Wait,
sure.
say
For
the
sure.
question again.
Using a sign out sheet is one of the use cases for the Raspberry Pi.
Oh yeah, absolutely.
Yeah.
Which like y'all can just start building if y'all can figure out like how to actually set up a GUI for that. For sure, we can just make one of the things be a sign up sheet. The nice thing about this model in particular, since each one is running a different Raspberry Pi, is that we can have different specifications for each monitor if need be. Like it's not the same program running off of 5 different monitors. It is in fact 5 different instances, which means we can have different specifications per TV if need be. Which one of them would be like that?
That being said, don't mess up the base environment because again, the Gemini is very in the SDK. They're very particular about where things are placed. So we've taken a lot of time to get everything set up, to get the environment variables set up correctly, so that minimum viable product, you guys can go in there and just start using the camera and build on top of that. So
You brought up a good point too, though. Now that we have a brand new Swamp Lab in support of the class, you can potentially develop software for the TVs in support of the new software engineering lab.
Yeah.
So there might be new use cases that you can now think of adding on.
Mhm.
Other things that you might not have considered, but I'll just throw that out there right now, since it's on the top of my head, is potentially a Discord bot that connects between the departmental Discord and the TVs as well.
mhm.
I think we have one
Speaking
more.
of Discord, bots,
Speaking of Discord, yeah. So
Oh, you want me to put it up there? Let me put it up
yeah,
there.
put it up there. The light's off right now, but we went ahead and if you go
Look at
on
this.
Discord on the Swing channel, you will see a voice channel. Feel free to join it and share that screen.
I saw one of you were on air. This is live. Yeah. Which if some of y'all joined about like an hour and a half-ish ago, you would have seen me and Mitch working it. That was you.
That was you.
That was you.
Oh, yeah.
That was us. Man, we saw you working on there. We were like, what the hell is this guy watching us? Yeah, no, we have.
You see me sleep.
Yeah, so obviously the idea of the lab is that each pod can kind of reserve the space, have access to the Raspberry Pis, have access to the Leap motions, but it's resource kind of limited, right? We only have one lab and we have like 13 different pods. So at any time you can reserve the space, but you can also just see what activity is there to see if it's open or not.
So you'll be being watched the whole time?
Yes.
Yeah.
I mean, you're being watched right now.
So that's there
Well,
too.
if someone's in there, if there's a pod in there, you want code, you're like, hey, try to run this.
Yeah. Wait, doesn't audio work through the TV?
It doesn't work through the camera.
Oh, that's true. Yeah, but okay.
These cameras do audio.
But that okay.
but
So
the
that
one in there
camera doesn't record audio, but out of the TV does have audio. So you could be like, "Hey, idiots," and they will hear you through there. They just can't talk back to you, which means you're in a great position. Okay, so that's that. Can you please mute? Can I mute? Can I mute? Thank you. What's up? Yes. No.
No, that's infrared, just because the lights are off in there.
Right, but it's you will see colors. You will see color once there's light. There just isn't light. So our deliverable. It's that. Do that. And I'm assuming Ted will be willing on this. If you actually oh, you changed it a bit. Okay, that's fine.
yeah, we changed it.
No, that's fine. That's fine. That's fine. Yeah. So our deliverable, just like submit some sort of proof that you're running one of the examples in the Swamp Lab. If you want, you can run it on your own machine. If you can get that working, that'd be awesome. So now you can take it home and do whatever you want. Also, as another bonus, just like a little extra bonus points, take a fun picture with your pod in the lab.
Yeah.
Sign up, do something there.
Yeah,
Yeah, exactly.
Good time.
Y'all have to embarrass yourselves too.
Also with the Swamp Lab, again, it's we put a lot of work into getting it up and running. But if you have any recommendations or any ideas for it, it's in kind of the bare bones status now. It is a living document, so to speak. So it definitely can be improved.
And I'm glad you said that. Also, just as an FYI for the Python binding. Oh, someone else. For the Python bindings I made as well, if you have any suggestions or if you want something specifically to be exposed because you have some idea. All right, that's enough of that. Yeah, good. If you want. All right. Is execution legal yet? No? Okay. That's fine. If y'all have anything specific you want to be exposed, maybe as an idea, if you have something specific, talk to me. No promises, but I'll see if I can make it happen.
Well, and these are instances where we can start creating tasks that Pod 5 can take on.
Yeah, that's true. Like maintenance tasks. Up to tasks.
Exactly.
Yeah.
That's the kind of work that we're going to be seeing as we move into cycle 1.
Right. For the entirety rest of the semester, this is what we are going to be doing with specifically your environment, your testing environment, your coding environment, the things that you are using. So the drivers, right. So if y'all have any problems with any of that, come to us. We'll see what we can do. We'll talk it out. We'll work with y'all. All right. We purposely made this wait, it's 4:14. Where's that constant? 45?
Yeah.
Okay. We made this relatively short on purpose so that y'all can ask a lot of questions because this is really important. Because this is what we're going to be going forward with for the rest of the semester. So if you have any questions, comments, concerns, feel free to air them. We were saying. You.
So like with the camera, like up to how many like points does it like measure? You know, like,
I can show you.
Yeah.
Yeah. Control
Can you
panel.
repeat the question as well?
Oh yeah. So what was asked was a beautiful question, which was how many points does the camera look at or control or track at once? Where the I can't see on this tiny is this thing, right?
Yeah.
Yeah. Control panel. All right. Watch and see the magic unfold.
Just so you know, the control panel is something.
Mhm. It does.
So you can see
track-
it hits basically every joint,
Right.
every flex point.
It is a little bit finicky because of course it is. But like you can see sometimes it tracks the second hand, sometimes it doesn't. But that's why I specifically limited the Python bindings, the OG Python bindings can track and deal with two hands at once. I specifically limited what I did to only one hand because that's simpler and it is kind of finicky tracking two hands at once. If y'all really want that, I can see if I can find a way to implement two hand tracking, but I got no promises because the camera itself is much more finicky with two hands. It's possible, but it kind of sucks. But you can see it is tracking the finger joints pretty well.
If you like slap it, it grabs the hand.
And like a unique ID.
Right. There's
Yeah, it
there's a
does.
hand ID that you can actually talk about, or not talk about, that you can actually track in the thing. You see how they're different colors. That's how you can tell.
Whoa.
Mine was two hands for a second. That's freaky. But yeah. Anyway, I hope this answers. Ow. Stop it. Somewhere.
lots of documentation.
But yeah, I hope that answers your question. It's the amount of power that this thing has when it works is pretty shockingly good.
Yeah, it is.
It's pretty good. It's pretty accurate. Like every individual joint you can access in some fashion. I know I didn't make a way to do that, but like if you want to override the function and do your own stuff, you're more than welcome to. You absolutely can.
Just so you know, I'm
sorry.
going to throw this out there, but if any of y'all are interested in JavaScript, there's a WebSocket server that allows you to use JavaScript.
There
as
is.
well.
Oh yeah, there is.
And I can work with any team that wants to use JavaScript as opposed to Python to get that up and running for you.
Oh, by the way, I don't know if we told you, we did manage to get your stuff running too.
Yeah,
Yeah.
yours is open. Right?
Did you have a question?
Yeah, I was gonna ask, will this work with my laptop camera or do I need one of those things?
You need this. This is a
Which is
special
why-
camera for this.
We were thinking, this isn't set in stone yet, but we were thinking about making a checkout system. No promises, we'll see about that later, but we do have each of the cameras ID'd. We're thinking of maybe making a checkout system. I don't know if that'll do it. I don't know if we'll do that.
We even have extra Raspberry
We
Pis,
do.
but we're still figuring out how that works. I don't know if we fully.
We're very limited on the emotions.
Yeah.
Yeah.
So that's the problem.
Yeah,
How much is that cost?
$200.
200. Yes,
So if you have
And it
$200 to
comes-
spare,
comes with a
be our
camera,
guest.
this cord, and a box.
That's why we have the Swamp Lab, so that everyone has 24/7 access. The Swamp Lab will never be locked, right? So
Yeah,
you
no,
can
you don't have to
come
ask for
with
something.
your pod at any time. If you want to come at 3 a.m. on a Sunday, that's fine.
Just please respect if other people have it signed out. You can always talk with another pod and see if you can swap and stuff. But if people have it signed, it is a small space. So just
Right.
keep that in
It
mind.
does it gets a little hot. and it gets very
We're-
crowded.
We're working on the
Yeah,
AC.
we're working-
Yeah,
yeah.
we've gone from bindings programmers to HVAC techs.
Yeah.
with that room. So-
We've done so much working on this, please.
When this workshop is done, I want everyone to kind of follow Pod 5 where the lab is at too, so that.
Yeah.
Yeah, we will have a miniature field trip over to there. Obviously, we can't fit all of you, but we will lead over there. Yeah, you.
Yeah, you should. Your own software.
So sign out sheets on Discord are interesting. There's no real way to block out times on Discord. So we could do that where you could put the time slot, but then people just need to make sure to read ahead and make sure they're not overstated.
If you find a good scheduler bot, let me know.
I mean, for NolaWorks, I've looked. Oh my, there's event bots like crazy, but nothing for basic blockouts.
Yeah, I
What's
mean,
that?
GitHub, we could probably do some. of
We could
the
write
GitHub
something real
projects.
quick. Little scheduler.
We figure something out. Like the we're gonna have a paper sign up sheet as just like a prototype thing, but we're open to expanding that
Yeah.
however we can.
Yeah.
Whatever's easiest for
We're going old school with the sign
Yeah.
up right now.
It'll
But
be cute.
I think
It'll
the
be fun.
best is your idea with the using this technology to then supplement the
Right.
swing lab and doing a sign out on that. That would be really cool to see eventually.
Did you have something else? Are you good? Okay.
This probably uses some neural network, right? For the tracking.
So I actually looked into that. And the answer is sort of. It's more complicated than just using a neural network. Like there for sure is some sort of model that they've generated that they're using here, but it's also just straight up they're also just straight up using like manual levels differences and things like that that you wouldn't see from some kind of generative model. It's partly neural network. I don't know the full details. If you are curious, I'm happy to research it because I'm curious myself. I didn't go full depth into it, but
Something similar before.
really,
And I used OpenCode, which is a neural network. to
Oh, yeah.
track Basically the same things. And I ran it on the RTX 3070 and was incredibly slow. So I'm just
Really?
I was amazed by the performance because I was getting maximum 15 FPS.
Wow. Yeah.
So I'm really amazed by it.
I wonder. It wasn't like generating a model real time, was it? It was just using a model it already had, right?
Yeah,
Okay, I was gonna say if it was generating a model in real time, that's why. Yeah. Oh, that sucks. I have no. That's interesting. I'm gonna have to. Do you know what it was called? The whole camera system and everything was called.
No, the neural network.
Well, what was the system called? The whole thing. Yeah.
So I have a Intel RealSense camera. I think the biggest difference is that OpenCode only runs on RGB data, and this one probably also utilizes the depth of it.
Right, because this is a stereo camera, and that helps a lot.
Yeah.
The fact that it's stereo cuts down a lot of the middle work that you would have to just assume, which was stuff like a neural network. Yeah, that's interesting though. I'm gonna have to look into that.
That camera, 4K.
Yes. I mean, maybe. I mean, monochrome camera.
I don't know.
You can probably check the specs, but this is what they're playing with right now is actually really good in kind of observation. Because one thing that you're going to want to get a good grasp of is what distance away from the camera do you have to be or to reliably to get input. And we're going to want to know that for when we mount those onto the monitor to know how close our users are going to have to be. So these are all going to be things that we're going to have to pay attention to since we're going to create a novel interface system with this device. What's the name of the camera?
Leap Motion 2.
And I'll just state that. I want to say that the first Leap Motion came out, I think, around 2012 or 2013. So this is about a technology that is about a decade old, and it's been kind of evolving over the last decade.
Good note about that. If you're ever trying to figure something out and you end up on forums reading about it, make sure to look at the comment date.
Oh yeah.
Because like I've
We
gone
run
down
some
rabbit
rabbits.
holes like, oh, that's how you do it. And it's like from 2011 and they've streamlined all of that since then.
So so you had Leap Motion and you had haptic.
Ultra haptics.
Yeah.
And they merged, so they're both two kind of supplemental hardware for like the kind of VR, like kind of emoted detection space, and so they became UltraLeap.
They still
And
sell
so
the
when
haptics.
they merged, that's when they kind of launched LeapMotion 2. It's a new and improved version of the original LeapMotion with better cameras, and that's the newer version the drivers have. So
Yep.
it's much more performant than the LeapMotion 1.
The touch free thing is really interesting, but it only works on Windows.
Right.
Yeah.
Which we're
And
not.
Gemini only works on Python, so we can't use
There
Hyperion.
is Windows on ARM, so we can always put a Windows OS on the Raspberry Pi if we
Yeah.
want to.
Yeah, we could.
I think we
If
did.
we want to play around with that.
We ended up not doing it.
Final note about the camera, it gets very hot, but that's okay. That's by design. So if you're ever feeling it, it gets hot.
It does get hot for such a tiny thing.
Just out of curiosity, does anyone have any 3D printing experience?
No.
Well, the only reason why I ask is another one of the tasks that might be outsourced to one of the pods might be to create a mount.
Damn. Yeah.
A mount for the TV.
I'm so glad you brought that
In
up.
absence of that, we can just duct
I mean, we can, you know,
tape.
yeah.
But it'd be nicer to have like an actual mount.
Yeah. You will have our eternal gratitude because do they have external mounts they sell? You know, did you see any?
I haven't
Yeah, I don't even
They
think.
make
I did
the
find-
ones for the VR. They do
Right,
make
they
the
have
ones for the
mounts,
VR,
but
and they
that's-
do make the ones for the TV, for the touchless that we can probably order on its own.
But
But if
that
they
requires it
have-
like that though.
Yeah.
if they have G-code files for those, you can just print them out.
I know.
You know,
So that's what I'm saying. That could be a task as well for one of the
yeah.
pods.
If someone comes across some G-code files or for designs for that, let me know and then we can print them.
We do desperately need mounts.
Yeah.
So please,
We're about to duct tape them for you all.
yeah. And it's not gonna look pretty. So do that.
Yeah.
Eeny, meeny.
Like monitor our files. Can you do that for TVs?
Yeah. No, it's whatever will work. Really.
I
Not picky.
haven't had time to look into it, so if you come across something.
On YouTube Shorts.
What we might look
Good old
into is
YouTube
the
shorts.
ones- We can probably look at the mounts that go in the VR headset and just use some tacky tape to mount it
Yeah,
to
that
the
works
front
too.
of the television.
Just some,
I mean, they're not a lot of weight, so
No.
we can really come up with something
Right.
fairly easy to get them mounted.
I was gonna mention on the GitHub organizations, there's a way to like add teams or like add your task to a team. So that way we can assign pods to it. That might be useful.
perfect.
Yeah.
Can
Yeah.
you repeat that
Yeah.
comment?
She was talking about how there is a GitHub Teams feature where we can have and add different teams and we can use that to help schedule tasks and whatnot. Similar to what the project management people were talking about too. We can use that to schedule tasks and potentially as a sign up sheet as well. So we'll definitely keep that in mind going forward. We're gonna figure out something. It's probably gonna be GitHub related. I don't know if it'll be Discord related. We'll see. But probably GitHub for sure. We'll cook something up.
In general, too, for like assigning the tasks.
Oh right, yeah, that would be a perfect thing for assigning
It'd
tasks.
be nice to have it all in one spot.
Yeah,
Yeah.
because everything's gonna be on the GitHub anyway. So absolutely. Plus,
Anything else before we go?
yeah, because if y'all don't have any questions, I have 10% watch. What's better left on the watch? Okay.
Woohoo.
Woohoo. We did it. Well, mostly. We're almost done. All right. Who's ready to go to the lab?
Okay, I'm gonna end the recording now.
It's gonna be really tight.
Sorry.